When you see a problem involving remainders, you should immediately think of mods. Let's see what happens when we increase n to n plus 1. For example, in mod 2, numbers alternate odd and even, so the remainder increases by 1 and decreases by 1 each time we increase n. When we divide by 3, the remainder increases by 1 until we get to 1 less than a multiple of 3, and then we subtract 2 from the remainder. When we divide by 4, we either increase the remainder by 1 or we subtract 3 from the remainder, and we see the pattern. When we divide by 5 and we increase our number by 1, we either increase the remainder by 1 or we subtract 4 from it. We see a similar pattern for all the other mods. In order for the sum of our remainders to be unchanged when we go from n to n plus 1, we have to balance some of these negative numbers with positive ones. Let's start by seeing if we can balance this minus 9 when we go from n to n plus 1 with a bunch of plus 1s so that the r of n function remains unchanged. When n is equivalent to 9 in mod 10, the next number is going to be a multiple of 10. So when we go from n to n plus 1, we subtract 9 from r of n, and we need to make up for that with these plus 1s. Unfortunately, the most that we can get, 1, 2, 3, 4, 5, 6, 7, 8, is 8, so we won't be able to make up for a minus 9. Let's see what happens when n is equivalent to 8 mod 9. Adding 1, we get a multiple of 9. Here is our minus 8. We can make up for that if we can get a plus 1 from all of our other divisions. We get plus 1s from these other mods when n plus 1 is not equal to 0 for all of these other mods. But if n plus 1 is a multiple of 9, then it's also a multiple of 3. So instead of adding 1, we're going to be subtracting 2. So this fails. Let's try the case where n is 7 more than a multiple of 8. This means n plus 1 is a multiple of 8, which means we lose 7 from our remainder sum. We have to make up for that with the plus 7. 1, 2, 3, 4, 5, 6, 7, 8. We can't do that. If we also get a minus 1 here, that's a minus 8, and then making up for that, 1, 2, 3, 4, 5, 6, 7, we're not going to be able to balance that. So this case fails. Let's try. N is equal to 6 mod 7. N plus 1 gets to be a multiple of 7. We lose 6 in the process. If we combine this with an n that is 1 more than a multiple of 2, then n plus 1 is an even number. Altogether here, we lose 7, and we can make up for that with our remaining 7 divisions. That's only going to happen if n plus 1 is not a multiple of any of these other numbers. 3, 4, 5, 6, 8, 9, and 10. So we want n plus 1 to be a multiple of 2 and a multiple of 7. Why don't we try 14? 14 is not a multiple of these other numbers. That means n is equal to 13. Let's check our work by finding the sum of the remainders when 13 is divided by 2 through 10. Dividing by 2, we get a remainder of 1. Dividing by 3, dividing by 4, dividing by 5, 6, 7, 8, 9, and 10. This adds up to 25. Let's check this function on 14. 14 is an even number, so we're going to lose 1 point in our remainder. It's also a multiple of 7, 2, 3, 4, 5, 6, 7. So we're going to go from 6 to a remainder of 0 here. Everything else is going to increase by 1. This is 6 more, 5 more, and 4 more than a multiple of 10. We notice that we lose 1 here, we lose 6 here for a total of 7, and we gain 1, 2, 3, 4, 5, 6, 7. So our sum remains unchanged, and that's our first solution. Before we move on, let's see if there's any other multiples of 7 and 2 that also satisfy this. 3, 4, 5, 6. How about 7 times 2 times 7, or 98? This gives us n is equal to 97, and we'll calculate this remainder function again. Divide by 2, 3, 4, 5, 6, 7, 8, 9, and 10. This adds up to 27. 98 is an even number again, so this goes to 0. It's also a multiple of 7, so this goes to 0. Everything else increases by 1. We lose 6 and 1 again for a total of 7, and we gain 7. So the sum remains unchanged. And that's our second solution. First, we note that we're looking for 2-digit numbers, so no other multiples of 14 are going to be valid. So let's try n is 5 mod 6, so n plus 1 is a multiple of 6. So we lose 5. If we take n is 2 mod 3, and then increase by 1 to get a multiple of 3, we lose a total of 7. This will work if we can find a number that is not a multiple of any of the other mods from 2 to 10, except 6 and 3. Unfortunately, if n plus 1 is a multiple of 3, it's also going to be a multiple of 2. So we won't be able to fully balance out negative 7 with plus 7. If n is equal to 4 mod 5, then n plus 1 is a multiple of 5. We lose 4 from our remainder function. But if this is true, if we do that and combine it with another number, that is 3 in mod 4, now we're losing 7, and we can balance that with a plus 7 from the remaining divisions. But unfortunately, if n plus 1 is a multiple of 4, then n plus 1 is also going to be a multiple of 8. So we're going to lose 7 as well. So this one isn't going to work. If n is equal to 2 in mod 3, n plus 1 is a multiple of 3, but then n plus 1 is also going to be a multiple of 6. That's going to give us a minus 2 and a minus 5, but it's also going to be a multiple of 9, which is going to subtract 8. That's too much. Finally, if n is an odd number, we're going to have an n plus 1 that's even. It's going to divide all the other evens. So this won't be valid either. So in total, our two solutions for n are 13 and 97. That's two solutions, or option C.